It's that time of year. ACR Convergence 2024 is nearly here. Join us in Washington, D.C. from November 14th to the 19th. Meet up with colleagues from around the world, enjoy thought-provoking sessions, listen to groundbreaking science, or join us for the Knowledge Bowl, Thieves Market, and the Image Competition. Register today at rheumatology.org. ACR Convergence 2024, where rheumatology meets. Hello, and welcome to ACR Journals on Air podcast. I am your host, Vicky Shanmugam. Lately, there's been a lot of excitement about artificial intelligence and training computers and robots to do some of the tasks currently done by humans. In some parts of the US, autonomous vehicles or self-driving cars are now a reality, but training a computer to function like a human is tricky. It takes, for example, about 45 hours for a human to learn to drive a car. But in contrast, autonomous vehicles or self-driving cars require about 11 billion miles of driving to match the driving skills of a human. While artificial intelligence and large language models are enticing, research, particularly medical research, is complex. So, is training large language models or automated intelligence systems to conduct some of the more automatic and repetitive research components really feasible? We are about to find out. The manuscript we will discuss today is A Novel Approach for Mixed Methods Research Using Large Language Models, a report using patients' perspectives on barriers to arthroplasty. It was published in ACR Open Rheumatology, and a link to the manuscript and disclosures are in our show notes from today. I'm really excited to be joined today by the senior author of this manuscript, Dr. Bella Mehta. Dr. Mehta is an assistant professor at Weill Cornell Medical College and assistant attending physician at the Hospital for Special Surgery in New York. She graduated from the Turner Medical College in Mumbai, India, and subsequently completed an internship and residency at the Westchester Medical Center. Her fellowship in rheumatology was at the Hospital for Special Surgery, where she now practices rheumatology and leads studies developing creative approaches to use big data to improve diagnoses and patient outcomes in rheumatology. She's received multiple awards for her work, including the Leon Lowenstein Foundation Grant and the Margaret Cadwell Research Scholar Endowment. Welcome to the show, Bella.
Thank you so much. And thank you so much for your kind introduction. I'm excited to talk about our work here. And, especially given that I'm very interested in large language models and looking at this paper where we're using it for mixed methods research. I think it's an exciting time in the field of rheumatology and medicine itself, where technology is being leveraged, especially in this work where we're leveraging that to understand patient perspectives regarding barriers to a joint replacement surgery. I look forward to our discussion and I hope it sparks interest and innovation in leveraging big data and large language models to enhance patient care and improve outcomes in our field.
Well, that's a great lead in because I always like to begin discussions with some background to the study. And the manuscript we're going to be talking about is a mixed methods study. So I wonder whether you could start by explaining what a mixed methods study is and why mixed methods research is a good venue to test out some of these large language models.
Great. So, mixed method study is a study which combines both qualitative and quantitative research approaches to provide a more comprehensive understanding of a research problem. So, when you integrate both these sort of methods, you capture both numerical data as well as the context or experiences behind those numbers. So, in our study, we chose a mixed method approach to leverage the strength of both these sort of data, qualitative and quantitative. And the qualitative data, which is providing deeper insights into personal experiences and challenges faced by patients who are with end stage OA and understanding the barriers to joint replacement surgery. And this sort of data helped us build a survey to quantify data to identify patterns and trends in a large cohort of patients where we could disseminate this survey to thousands of patients, for example. So, testing large language models in this context was particularly advantageous because these models can efficiently process and analyze large volumes of qualitative data. They can identify themes and patterns, which are usually done by manual analysis. And it also has the capacity to generate surveys, which sort of allows us to gain a more nuanced understanding of the barriers patients face. But the ultimate goal is to inform clinical practice and interventions in the future.
Great. So I think everyone listening to this discussion probably has heard of ChatGPT. I wondered if you could tell us actually, what does GPT stand for? Why did you think you could train this model to be as effective as a researcher with years of medical training and scientific experience?
Absolutely. So GPT stands for Generative Pre-trained Transformer. It is a type of artificial intelligence model which uses machine learning to generate human-like text based on any input it receives. The good part about this is that it can generate new content and can autonomously learn from data. So a lot of machine learning programs in the past needed to be trained, but this is something that can learn and generate new content. And some things like ChatGPT, they are done by these companies, which is trained on like tremendous vast amount of text data, which allows it to understand and generate natural language. I call them natural language processing on steroids. I mean, not only steroids, maybe pulse steroids. So they are pretty powerful models. They, if a human starts reading since the age of 8 or 10 throughout their lifetime, like every single day, these machines are trained on like 1,000 times the data that a human can even consume in a lifetime. So, since they are trained for natural language, we tried to see, and again, we didn't know if it'll do a good job or no, but that was the process of this study, saying that if it can understand language, can it understand qualitative data that the patients are essentially conversing in a qualitative interview? Again, you know, while I think GPT models are great, they are not a replacement for experienced researchers. They can be powerful tools, though, to assist in research. And just because of the way it is trained, it can identify patterns. And thus, we thought that it could identify themes and insights from qualitative data that can make efficiency a little more and make things faster for human researchers who are already experts at that. Moreover, by leveraging GPT, we can augment the capabilities of the researchers so that they can focus on more nuanced and complex aspects of research that require human expertise. Again, the goal is to accelerate the research process and potentially uncover new insights with this.
So I wondered if you could walk us through the study's design. So figure 1 in the manuscript has a good visual representation, but because this is audio only, can you walk us through what you and your research team did?
Yes, so first we interviewed patients with end stage osteoarthritis to understand their barriers preventing them from getting a joint replacement surgery. We had about 6 interviews and 1 focus groups asking open ended questions to gather detailed responses. These interviews were conducted by trained researchers who created a topic guide to sort of standardize these questions. In this mixed methods approach, we first analyzed these interviews to find common themes about what are the problems or what are the barriers these patients are facing. And once we found those themes, using this qualitative data, we created a survey. A lot of us researchers looked through the themes and made a standard survey that can be disseminated to a larger group of patients. So, what we did in this particular paper is we compared two methods. One is the traditional human analysis versus the AI or the large language model, which in our case was ChatGPT 4. So, when human researchers analyze qualitative data, which is a lot of text interviews, they are usually sort of transcribed, and human researchers use NVivo, which is a standard software to code the data and identify themes. And Usually they meet regularly, agree on these themes, and once it's agreed, they analyze data to ensure consistency. So, just for the AI part, we fed the same interview transcripts into GPT-4 into manageable segments. Again, there's only around 1,000 words that we could put in at that time, each time. And we created standard prompts, which are essentially what we call as instructions to the large language models to identify the themes in each segment. At the end of it, we combined all these themes from each segment to find the most prominent ones because we had the limitation of the 1,000 words. After identifying themes, we created surveys. Both humans and ChatGPT created surveys. Humans, they did it by consensus. ChatGPT, we asked it with prompts saying, can you make a survey for us using these themes? And gave them instructions saying this should be like a Likert scale, 0 to 4 or 1 to 5, however you need it. And then what we did is we compared both the themes that we got from the qualitative data and then the surveys that was generated both by the humans and the AI. Also, one of the things that we wanted to emphasize is the time it took for each method to do this, to help us understand the effectiveness of AI in this type of research.
So, what's the answer? Who does a better job, the robots or the rheumatologists?
Haha, that's a great question. I think that's the key question, right? But in our study, both methods had their strengths. Human researchers brought their clinical expertise and deep understanding of the context, which I think is invaluable for interpreting nuanced patient experiences and ensuring the relevance of the themes that are identified. There was a systematic way of coding, reconciling themes, which did ensure consistency and accuracy. On the other hand, ChatGPT 4 demonstrated its ability to process and analyze large volumes of qualitative data quickly and efficiently. It could identify themes independently, and the results were more or less comparable to the human researchers. It does suggest that it could be a powerful tool to assist researchers, but it was not 100% overlap. So I wouldn't say it can replace it, but it can definitely save time in performing the initial analysis, especially handling large data sets which come out of qualitative research.
Yeah, I'm going to ask you because the way you ran this study somewhat distracts from the results. What were the patient perspectives on barriers to arthroplasty?
In a way, this paper was focusing on the way we can analyze the data. There's another study which goes into much more depth on the surveys. But here's the several key barriers that emerged. One was fear and anxiety, which was like many patients expressed fear and anxiety about the surgery itself and the recovery process. The second was lack of information amongst patients regarding the benefits and risks of arthroplasty. The third was cost of surgery, which was associated with expenses, which seems to be like a big barrier in a lot of these patients. Again, these are interviews conducted in a particular disparity group that we were looking at. And difficulty in access of healthcare services was another theme that came around. And lack of adequate support systems, such as family or community support during recovery period, was another significant barrier. And an important one is that some patients had personal or cultural beliefs that influence their decision making regarding the surgery. So I think all of these need to be taken into consideration both by physicians and policymakers when thinking about acceptance to arthroplasty.
Yeah. And what did you, as a researcher, learn from running this study? What are the limitations of large language models, and how can we harness their power without succumbing to their pitfalls?
I think what we found is that large language models can be highly effective in assisting both qualitative and quantitative aspects of the mixed methods research. Specifically, the surveys that the large language models generated were pretty good and almost like could save so much time as a starting point if we use that draft. But there are important limitations, right? While they can efficiently process large volumes of data, they lack the nuance of understanding the context that humans or like rheumatologists or researchers can bring to table. The human researchers did conduct these interviews, which gave us good quality data to analyze. So the theoretical frameworks that the interviews were based off, the ability to interpret subtle nuances and emotional undertones is something that only humans can pick up right now, though these LLMs are being programmed for many more things going forward. Additionally, the wording and the detail in the themes and the survey generated by the large language models were not 100% overlapping with what we created as humans. So it does affect how participants perceive and respond to these questions. So we need to take a few steps to make sure that we're working with LLMs and we're doing it right. One is obviously have human oversight, refine and customize the prompts, and make sure that we ensure transparency. Even when we're processing data for a study like this, we had an IRB approval, made sure everything was de identified. Some of our other studies that we are running now are in closed LLMs where the data doesn't leak out. And I think further research and development needs to happen here to make sure that we are doing it right, doing it safely. But I think with all of this, I think there's great promise, and there is definitely limitations, but as long as we understand them, we'll be leveraging it
Yeah.
efficiently.
And as someone who uses these LLMs and big data models a lot, how do you think we should approach the use of AI in research more kind of globally? Do we run the risk of quantity surpassing quality? And do you have any advice for reviewers and editors reviewing manuscripts of studies that use these tools in research? What should the reviewers be on the lookout for?
AI and especially large language models are here to stay. They have incredible power and efficiency, cannot replace humans, of course, but humans who understand its capabilities and adapt quickly will have significant advantage both in research as well as in clinical care. And if we maintain rigorous standards, fine tune these models, and work with LLMs, understanding its limitations, I don't think we will risk quality because that's the biggest concern. When it comes to reviewers and editors, I mean, I get a lot of these, reviews solicited because of these papers. I think that some of the key things to make sure that the methods are transparent, things are written out, what was done, what was not done, assess the exact role of the AI, whether it was well integrated, whether its limitations are acknowledged and addressed. And I think at the end of it, sometimes with these papers, not lose focus on the big insights and the impact. AI is just a method, but not the end goal. The end goal is still sort of improving patient care, patient outcomes, improving the research understanding. Make sure that the ethical and practical implications are considered. And one other thing is that if reviewers and editors are not understanding the methods completely, have an additional AI reviewer if needed, because things are getting very, very nuanced, and not everybody would know all kinds of AI too.
Yeah. I wonder whether you could also address something that we all know happens when these computer tools are used, which is that sometimes they hallucinate, I guess, a little bit like on being on steroids. If we ask the computer to run these algorithms, what checks and balances should be in place to ensure that we get quality output and not just garbled garbage?
True. Again, like I said, large language models are natural language processing on steroids and pulse steroids. So, yes, people hallucinate when they are on steroids. So, I think all of these models can hallucinate. But to tackle this, we need to have some solid checks and balances in place. First, it's crucial to cross verify AI results with human analysis. Just look at the data, see if it makes sense. And a real world context or accuracy does help. Second, validate these results using established benchmarks and data sets. This helps in confirming if this is reliable and consistent with known data. Third is what is known as RAGs, or retrieval augmented generation. We didn't have to use it for this study, but this is a concept, the RAGs, which is a framework to improve the quality of large language model generated responses. How I can explain that is that you can custom program the LLMs to give you better responses. Basically, ground these responses to external sources of knowledge to supplement the LLM's internal representation of knowledge, to make sure that the hallucination is, if not zero, it's minimal. And again, regular updates, fine tuning these models is important. And again, this is a fast moving field, so new data and standards emerge. Keeping up with those tools will help too. And again, being transparent, this is what we did at this point of time is important, and documenting that and how decisions were made. And again, if there is a problem, flag those results and put the measures in place to make sure that even though there can be hallucinations, sort of focus on the big picture and try and minimize them.
Mm-hmm. And more broadly, I'm going to take you to a kind of larger, more metaphorical question. Do you think these large language models have a place in clinical medicine outside of their research use? Do you ever use them in your clinical practice?
Absolutely. I think large language models definitely have a place in clinical medicine beyond just research. I guess I use them frequently, or probably daily. For instance, I rely on them to draft appeal letters for biologics and disability claims. This helps streamline the process, ensure clarity in communication. Again, given English is not my first language, LLMs is like an advanced version of Grammarly for me. They help me polish scripts for presentations, refine tricky emails sometimes. For research, I use statistics like R, and it helps debug my statistical code and helps save a lot of time. But sort of going back to clinical work, I think a lot of papers that you see focusing on large language models are looking at solving like USMLE questions, or sort of solving clinical diagnostic problems. But I think their biggest potential lies in serving as adjuncts to our work. We don't want them to replace rheumatologists, but assist us, right? But the things that it can help is they can make diet plans, exercise plans, translations to different languages. At least sort of a first draft is very good. Educational material for patients, and those are papers that are also coming out. Again, they are a good starting point. Those drafts still need to be reviewed, but saves a huge time. One of the things is that Epic, which is our largest EMR, is also incorporating large language models to answer patient questions, right? Some of the beta versions are already out, where if patients ask about their, if they have certain questions, it actually automatically generates a response, gives it to the physician, and the physician can either edit it or send it as is. So it's coming in mainstream, especially with multimodal large language models now coming into play with like image, audio, text, contextual data integration. We're just scratching the surface, even in clinical medicine, for this.
Yeah. And there's a lot of lived experience, though, in the field of rheumatology. I mean, we look after patients with rare diseases and rare presentations of more common diseases. So just like computers, we need to be trained. And the repetition is kind of an important part of that training. You mentioned briefly just now computer models to solve USMLE problems. How do you think these computer models can be helpful or harmful in medical education? And what's your approach to using them in medical education as well as kind of clinical medical decision making?
Absolutely. I think I'm a big proponent of adapting new tools rather than avoiding them. So, embracing computer based models in medical education can offer significant advantages if we understand their risks and benefits. So, these tools can support learning by helping generating study materials and guiding students through complex rheumatology cases for the first time. So I have med students who rotate with me, and they're probably seeing a lupus patient for the first time. And they're all using this. Either we know it or no. So, for example, I asked them, like, what questions should you ask on a review of system for a lupus patient or another autoimmune patient? These are questions that these large language models are very good at basics for at least trainees. So I think, again, using them as adjuncts to traditional learning can be a huge boost. Again, but maintaining critical thinking and hands on experience still remains crucial in medical education. So, yeah, I think there's a role for it in every aspect as long as we know what we're using it for.
Mm-hmm. Mm-hmm. Yeah, and there's sort of nothing that beats lived experience, really, right? And that's what makes, I think, the art of medicine. So, as you know, I'm always very interested to have our investigators tell us a little bit about their own background and their lives and how indeed they make decisions. So, I was wondering, Bella, could you share with us, how did you get your start in rheumatology, and did it involve ChatGPT?
No, I'm not that young. ChatGPT came in like a couple of years ago. But, I am an international medical graduate. I did med school in India, and I was curious about rheumatology. Again, med school for me was mostly textbooks. We didn't do too much research, and sort of rheumatology and research got hand in hand with when I first came to the US. I was curious about it. I did a rotation and then fell in love with it, which made me decide to come to the US in order to pursue rheumatology. So, yeah, and I think throughout I was interested in data of all kinds, understanding data. So, I sort of during residency learned how to code myself, sort of you looking at YouTube videos and whatnot. I was always intrigued by data, and I think when ChatGPT came, I was just playing around with it, honestly, and seeing what it could do to help us. And now have multiple studies, including this one, honing how these huge language models can help us solve some of our research problems and improve outcomes in patients.
All right. Well, so you kind of filled in some of the background about your move, but would you mind sharing a little bit more? What brought you to America? And were there any mentors who helped or guided you? Do you have advice for others who might be embarking on a similar journey as an IMG?
I think the journey as an IMG is a little more tricky. And, I've had several people throughout my journey who've helped me. So I would say coming to the US was because I wanted to do rheumatology and I thought I'd be trained well. Staying in the US over the long period of time was because I got interested in research and data. And once I sort of learned to code in residency, during fellowship, I did a full time master's in public health. Sort of that also formalized my research skills or my interest in research. I would say when I first came to the US as a med student for a 1 month rotation, I met a rheumatologist who influenced me a lot. I subsequently did research with him. And then a lot of people here at HSS have been mentors. And again, I have a unique story as an IMG because I have not had like one mentor who's like guided me throughout. I have had several mentors who've helped me at critical periods of my career. And thus, I have been, in a way, adapted to several different schools of thought, I would say. And at this point, I feel like I'm also becoming a mentor. And it's a journey because you take experiences from your mentors, let it be Dr. Goodman or several others, I would say. And now, even for the study that we just talked about, Insa Mansat, who's the first author of the study, was a research assistant with me and now a med student, first year med student who's been taking on these challenges with me. So, again, I also feel that a lot of young folks are interested in AI, and rheumatology itself will attract a lot of these new talent.
Yeah, no, I think that's definitely true. Looking back, you've been in the US for more than 10 years. You've obviously had a lot of training. You've spent a good amount of time in clinical practice in an academic setting. If we plugged your experiences into ChatGPT, what themes would come out, do you think?
That's interesting. I think the biggest theme that would come out, especially for somebody like me coming from India with very minimal research experience, would be adaptability. I've always been able to adapt to different settings, learned new things, and I'm not scared to try new things. And that's the theme that would come out when you sort of see my CV or the papers that I've come out with. I think a lot of training and academic settings also teach you so much. I think I'm learning every day new things, and again, I think as long as people can be open, adapt, and try things, we'll be able to find new discoveries.
Yeah, edge the barriers, right? Edge the advances. So you obviously do a lot of research using these large language models. And when you do a lot of research, it means you're doing a lot of writing. How do you, as a scientist, like to write? Are you someone who can write anywhere? Do you need dedicated writing time? Do you write from scratch, or have you ever used these computer models to help you generate a first draft?
English is not my first language, so I need to dedicate time to write. Do I use LLMs to generate drafts? No, because I think this is a gray zone and I don't want to use them right now. Maybe in the future, but again, I use them almost as Grammarly for me, but I can't write anywhere. And I need to dedicate time, but it's not that I can sit one day and finish a whole manuscript. So what I do is I have pieces. By pieces, I mean that maybe I start with the results section or the method section and make sure that I have 2 paragraphs of the method section written. And when I write, I can write it in a way that it could be literally in bullets. It may not even be fully constructed formed sentences, but as long as the big points are in, that's how I start writing and then refine it as I go. I think, again, there's so much more to learn when it comes to writing, but I'm in this process. It's a journey, but yeah, it's been interesting.
Yeah, I feel like that's true for many people, that you evolve as a writer as you evolve as a scientist. Don't worry. So that was a really fun discussion, Bella. Thank you so much for sharing all your insights. I've very much enjoyed talking to you about the power and peril of using AI in research and the importance of humanity in that process.
Thank you so much. And this was really nice talking to you and talking about something that I'm really passionate about. Again, like 3 years ago, I didn't know I would be doing this. And now I am doing multiple studies using language models. But I think this is where in the next 5 to 10 years, we'll see so much more movement, and it will be interesting to be an early adapter. Is That's what I call it. I'm not an expert here because this field is so vast and so fast moving, but definitely an early adapter. So hoping more would come and join here.
That's great. So my thanks today also go to people like Bella who like to experiment and push the boundaries of research, try new things so that we can all learn. I, on the other hand, just continue to ask the questions that pop into my head, and I can assure our listeners that AI was not used to generate this discussion. Thank you all for listening to this podcast. ACR Journals on Air is a production of the American College of Rheumatology. Please follow at ACRheum on social media. Email us at podcast@rheumatology.org and rate and subscribe to our podcast at acrjournalsonair.org or wherever you get your podcasts.